Okay, so in our previous class, we discussed about different searching techniques. We discussed about two types of searching techniques. One is a sequential search, and another one is the binary search. Okay, in sequential search, we discussed about three different variations of sequential search. Normally, if the list of elements, okay, suppose if you want to perform if you want to find a number in the given array of numbers, okay, and the list is unsorted, in such cases we will go for the sequential search. In sequential search there are three variations: sentinel search, probability search, and ordered list search. And if the list is sorted, then we can go for binary search. Suppose if the number of elements in the list is more, then what we can do means we can perform the sorting operation, and after that we can implement the binary search concept. Compared to the sequential search, binary search algorithm efficiency is more. So this is what we discussed in our earlier session, okay, in last session. In today's session, we will discuss about one more searching techniques, that is hashed list search. First, we will discuss about introduction, then what are the different hashing methods available, and then what is a collision, and what are the different collision resolution techniques available. So this is what we are going to discuss in today's class. Okay. So first, what is hashed list search? What is hashed list search means? Suppose if we have in our linear search, okay, in linear search and in binary search, in both cases, what we performed means we have taken each element and we compared whether it is equal to the target element or not, or target value or not. Like that, we performed many comparisons to find the given value exists in the list or not. Okay, so this is what we implemented in the sequential and binary search. But in hash search, we will perform very few comparisons compared to the linear and binary search. Here we will perform one or two comparisons only. So based on that, we can directly access the address of the element. Okay, so this technique, okay, so the mechanism which converts the key into address is called as a hashing method. Okay, so suppose if you have a student race number, then from the student race number, it is possible if we can generate the address of that particular student. Address means in memory where that particular student information is stored. Okay, so the key to address mapping. Okay, so that is what called as a hashing techniques, key to address. Okay, a hash search can be easily implemented in arrays. Means we can implement the hash search in files concept or in linked list concept. Okay, so different in most of the data sets we can apply the hash, but very easy way to implement hashing is the arrays concept. Okay, so that we will see an example program later. Okay, first we will discuss about the introduction. Okay, in a hash search, the key, okay, the we will convert the key into address through some algorithmic function. That algorithmic function is called as a hash. A hashing is a key to address transformation, okay, in which keys mapped to addresses in a list. Okay, suppose let us take the array example itself. If we have an array of 10 student information, okay, so 10 students are there in the array. Okay, then array what we can do means we can have an array size of 11. Okay, in that 0th location we can leave empty, and in first location first student details, second student details, third student details. Like that we can store the student details. Now if the student race number, if it is starts from 101, 102, 103, okay, the simple modulo operation we can use as a hash function. Okay, means the key value mod 10 means 101 mod 10. What it gives means, what is the value of 101 mod 10?
One, sir.
Students.
One.
Correct.
One.
So the 101 student, okay, his race number is stored in the first index of the array. The same way 105 mod 10. So the 105 student, his details is stored in the fifth index of the array. So this modulo operation is one of the simplest form of a hashing technique. Okay, we will discuss about different hashing techniques. Okay, in that simple modular division. Okay, so this is one of the simplest hashing technique. So this is an example. Okay, 101, 102, 103. These are all the keys. The modulo operation, that is a hashing function. Directly we will get the index value in address in the array in which index that particular student details is available. So the key is converted into index or address. So this conversion process is called as the hashing. So this is what hashed list search. Directly we will convert the key into address. Okay, any doubt in this? Okay, see here, this is an illustration. Okay, so here key values. Okay, here hash function. Okay, any hash function which converts this key into some address. So 102002. So this is the key value. After applying the hash function, we are getting 5. So this particular student's record or this particular employee's record is available in the 5th index of the array. Okay, or 095, we are applying some hash function and his details is available in the 100th location of the array. Okay, so this is key to address mapping. Okay, so that is what the purpose of hash function. Okay, so using this we can perform the searching operation, hashed list search. So this is an example illustration. Now in this we need to understand certain things. Okay, so what are the things means? Suppose if we have more than there is a chance that sometimes more than one keys will generate the same address value, or more than one keys will point to the same address. Okay, the same modular division you can take. Okay, so means 102 raised number and 202 raised number. If the modular operation is at 10, then both will give the address as a 2 only. Okay, 102 raised number, 102 mod 10 is a 2, 202 raised number. Okay, modulo 10 is also 2. Okay, both is pointing to the same address, the same index location 2. Okay, suppose if we are facing any scenario like this, okay, then this is called as a synonyms. Okay, sometimes more than one keys will hash to the same address location. The set of keys hashes to the same address is called as a synonyms. Okay, and because of this, what will happen means collision will happen. So we are when we have some memory space, and if more than one keys generates the same address, then it is not possible to store one record over the other record. Okay, so what we need to do means we need to find different location other than the generated location. Okay, so this avoiding this collision, okay, avoiding this collision is called as a collision resolution technique. Okay, the event is called as a collision, means 102 mod 10. We stored the 102 that particular student's record in the second index. After that, we are getting one more student record, 202. So when we give 202 mod 10, it is also giving the 2 as the index address. But in the second index, already the details of the student 102 is available. So we cannot store the details of 202 in the same location. What we need to do means we need to find any other empty spaces available in the array. Okay, using some logic or using some function. Then we need to apply the function to find the free space, and there we need to store the 202 student record. Okay, so this finding the next available address or next available free space, this function is called as a collision resolution technique. Means because of some collision we are trying to find some alternate place, collision resolution technique. Okay, and here in this example, in this picture, we can find it. First, hash a means for a we are applying the key and applying the hash function for the key a, and it generates the 8th location as an address. Okay, and we stored the details of a in the 8th index. After that, again the record B, we are applying the hash function. It is also generating the 8 as the address. But in 8th location, already A is available. What we are doing means we are applying some collision resolution technique and finding the 16th location. Okay. And in 16th location, we stored B. Now, we are trying to find the address for the C, means the third record. After applying the hash function, the C generates 16 as the address. But in 16, we already have the record B. What we need to do means, again, we need to apply some collision resolution technique and store the C in the 4th location. Okay, so this is what collision and collision resolution techniques. There are different collision resolution techniques available that we will discuss in the later slides. Okay, and a collision occurs when a hashing algorithm produces an address for an key and that address is already occupied. Okay, in such case, collision will occur, and the address produced by the hashing algorithm is known as a home address. These are some of the important definition. What is home address? The home address is the address produced by the hashing algorithm. Okay, means when a key generates an address, that address is called as a home address. Okay, and the memory that contains all the home address is known as a prime area. In an array or in a list, a certain part of the memory or certain part of the cells we can consider as a prime area and others as a secondary area. Suppose if any collision occurs in the prime area, then we can solve the collision by storing the next record in the secondary area. Okay, so that we will cover in the collision resolution part. Okay, so here in this slide, what you have to understand means what is a collision, what is a synonym, and what is home address. Okay, so this is about collisions. When we when we go for the hashed list search, for sure we will face the collision collision scenario. In case of collision, we have to apply the collision resolution technique. Okay. And one important thing is when we store the value. Okay, so when you are storing the data or record in the hashed list using the hashing algorithm and the collision resolution technique. Okay, the same must be used to recover or access the data. Suppose for storing the record 102, okay, we stored it in the second index, and when we found that 202 collides with the 102, and we are applying some collision resolution technique, and we are storing the 202 in some other location. So what function we have applied to find the next available location? Okay, the same functionality must be used to recover 202 also. Okay, so when we are trying to search 202 student record, what we will do means 202 mod 10 we will apply. It will go to the second index. But in second index, the record available, what is the record available is a 102 student record. 102 is not matching with the 202. So we have to search for the collision resolution technique. What is the collision resolution technique applied in that case? Okay, used based on the same collision resolution technique, we need to go to the next location, and there whatever the record available, whether it is equal to 202 or not, we have to check it. Okay, each of this searching process is known as the probing or probe. Okay, each calculation of an address and test for success is known as a probe. Okay, the next is a hashing methods. What are the different hashing methods available? Hashed list search. What are the different hashing methods available? Okay, so basically in hashing methods, okay, so these 8 methods are available: direct method, modulo division method, mid-square method, rotation method, subtraction method, digit extraction method, folding method, and pseudo random generation. Okay, so in this direct and subtraction method, these two methods are very simple and one-to-one mapping. It means that each key will be mapped to only one address. there is no chance of collision in the direct and subtraction methods. Okay, direct method and subtraction method, these are called as a one-to-one mapping. Each address will each key will generate only one address. Okay, and in this there is no chance of collision. But what is the disadvantage means we cannot use the direct method and the subtraction method for the large list of values. Okay, so first we'll discuss about what is the direct method and the subtraction method, then we will discuss about its disadvantage. Okay, first direct method. So what is direct method means? Okay, whatever the keys we are having, the keys directly we can use it as a address. Okay, without any algorithmic manipulation. Okay, so how means, suppose let us take two example scenarios. The first one is if we wish to calculate the total monthly sales, okay, by the day of a month. Okay, suppose if you take a month with 31 days, okay, we need to store each day's sales. Okay, so how we can create means we can create an array of size 31. Okay, and array of size 32. Okay, so means the 0th index we can leave it as a empty. So totally 32 cells. So day 1's sales, where we day one sales where we can store means we can store it in the index 1. Okay, sales of 1 contains the day 1 sales. Sales of 2, second index contains day 2 value. Sales of 3, third index contains third day's value. So the day is the key here. 1, first day, second day, third day, fourth day, fifth day. Day is the key, and the same day directly mapped to the index of the array. Okay, key is the address. So this is what direct method. The same way, employee information system, if you are taking, suppose if the array contains 100 employees. Okay, if a company contains 100 employees, all their details you can store it in an array of size 101. Okay, why we are taking 101 means the 0th, the first element. Okay, we are leaving it as a empty. So the employee numbers starting from 1 to 100. Okay, so the first array contains the first employee details. Okay, employee ID is 1 and his details is available in the first index of the array, and employee ID is 2, his details is available in the second index, and so on. So this is the example for direct method. Okay, and this is a one-to-one mapping, and here there is no collision. Okay, because each key is directly mapped to address. Here there is no chance of collision. So collision will never occur in the direct method. But the disadvantage of this direct method we will discuss after discussing the second method. What is the second method means? Subtraction method. So what is the subtraction method? So subtraction method, suppose normally if you are taking employee ID or your ration numbers, okay, it will not start from 1. Okay, it will prefix with some large number. So normally what we will say means even though a company contains only 100 employees, the employee numbers will start from 1001. So 1001, 1002, 1003, 1100. Okay, so the 1000 is a constant added to the each employee. So what we can do means we can subtract that constant. Okay, so obviously what we will get means we will get the employee ID 1 to 100. So here what is the hash function means? Okay, subtracting some constant from the key. Here key is what? It is employee ID. What is employee ID? 101, 1001, 1001, 1002, 1003, 1004 to 1100. So this is the key. And what is the hash function here we are applying means the employee ID minus constant. Here what is constant? 1000. So employee ID minus 1000. What it will give means it will give the address. Okay, 1001 minus 1000, it gives 1. So the 1001 employee ID, his record is available in the first index. 1002 employee ID, 1002 employee ID minus 1000, it gives 2. So his details is available in the second index of the array. So this is the subtraction method. Okay, so this is also more or less equal to the first method, direct method. each key gives one unique address. Okay, there here also there is no chance of collision. Okay, it is simple and guarantees that there will be no collisions. Okay, so it is a simple method. But what is the limitation of this method and the previous method? That is a direct method. The limitation is it can be used only for a small list, okay, in which the key is mapped to the densely filled list. Okay, it means that if the list is very small, for such case, okay, suppose if you are going to use the arrays concept, okay, only that we can use it. Okay, let us take some other example. Suppose the instead of storing the employee ID, okay, in the company, the employee ID what they are using means instead of giving their own employee ID, they are planning to use the Aadhaar number or the social security number as the ID of the employee. Okay, so if you take the Aadhaar number, it contains some 12 digits. Okay, but if you want to store the 12-digit index in your array, then that much length array you need to create. Okay, but what you are going to store means you are going to store only 100 employee details. So if you want to map the Aadhaar number as an index, that much length of array you need to create. That is the first thing. And in that array, in that much size of array, we are going to use only 100 cells. Okay, that's why it is not possible to use this direct method and subtraction method for the large size of list or the places where the key is not easy to convert into address. In such cases, it is not possible to use direct method and subtraction method. Here, the direct method and subtraction method, okay, here these two are called as a one-to-one hashing method. Means only one key hashes to each address. The addresses will not have more than one key. Okay, these two methods are very simple and easy to understand method, direct method and subtraction method. Any doubt in this?
Sir,
Yes.
sir, in this method also we will leave the 0th index as empty.
Yeah, yes.
Or
Yes, we
sir,
will
what
leave
is the
it.
purpose?
What is the purpose means?
Sir,
Leaving
I
the
mean,
first
why we are
cell as
leaving?
an address. Yes. Why means the employee number is starting from 1. The employee number cannot be 0. Okay. So suppose
Okay,
if
sir.
we have employee ID as a 0, then we can have the array size from 0 to 99. No issues. But mostly we will not have an employee ID as a 0. Correct?
Sir, for our understanding, we are using like this.
Yeah, for our understanding, we are
or,
using like this.
okay,
For
okay,
our
okay, sir.
understanding and most of the generic concept.
Okay, sir.
Normally, student ID or employee ID, it will not be 0 now. It will start from 1 to means some numbers 1 to 100 like that. Okay, that's why we are leaving the first cell as a empty.
Okay, sir.
Okay, fine. Any other doubts in these first two methods? Okay, we'll move to the next method. So the next method is a modular division method. So this is what from the beginning onwards we are discussing. Okay, so modular division method is one of the very simplest hashing functions. Okay, you can write a simple algorithm using this modular division method. Okay, so here what we will do means how we will find address means the key will be divided by means modulo division by the list size. Okay, modular division by the list size. Then each of the record will be stored in different index position. Okay, modular division. So this is one of the hashing method. Okay, and here what is the important thing means taking the array size. Okay, so array size, it is always better to choose as a prime number. Okay, if you are choosing it as a prime number means the number of decisions happen is less and the collisions also will be less. Okay, compared to the any numbers, if it is a prime number, okay, then we will get less number of collisions. Okay, so see here. In this example, we have taken 1 2 1 2 6 7. So 1 2 1 2 6 7. Here the list size is 307. Okay, so 307, if you are taking as a modulo, okay, 1 2 1 2 6 7 modulo 307, we will get remainder as a 2. Okay, so in the second index we will store the record of this particular person. Okay, the next value, key value we are taking and performing the modulo by 307. So we will get 306 as the reminder, and this particular person's record will be stored in the 306 index. Okay, so this is the third method, modulo division method. Okay, so here in this illustration, in this list, in the bottom we have given one example also. Okay, search finding the 1 2 1 2 6 7. Okay, his details, and his details is stored in the index position 2. Okay, and this first two. Okay, so this 1 2 1 2 6, these are employee IDs or student IDs or any key number which is used to identify a particular record, uniquely identify a record. Okay, these are some keys to identify a record. The keys are converted to index position or address or whatever we call. Okay, so by applying the hash function. Here, what is the hash function means? Modulo operation is the hash function. So this is the third method. Okay, and fourth method. So what is the fourth method means? Mid square method. So in mid square method, what we will do means first square the key value. Okay, whatever the key value given, square the key value, and from the result take the middle portion. Okay, so based on your list size or based on your array size, okay, the middle 3 digits or middle 2 digits or middle 4 digits to take as a address, and in that particular location you can store it. Okay, this is what mid square method. Okay, see here, here 9452, this is a key. Squaring this is, we are getting this result, and from here the middle 3403. Okay, so this is the index. So in this index we will store the record of 9452 employee. Okay, so this is the other way. Okay, for large size of lists we can use this kind of hashing function. But here, what is the means? What is the disadvantage? Sorry, what is the limitation of this mid square method? Means the size of the key. Suppose if the size of the key is more, then squaring that key will give more digits. Okay, sometimes it is more than the size of the integer, so we may not able to process the that much big integers. In such case, what we can do means, instead of squaring the entire key, we can take a portion of the key and square it, and from that we can extract the required part, required index values. Okay, so that is what as a variation given in the right side. Okay, suppose if 379452, this is a employee ID. From this employee ID, we are taking only the first part, 379, and we are squaring it. We are getting 143641, and from here we are taking middle value, that is 364. Okay, it is a 3 digit. Suppose if you it is a if your list allows 4 digit indexes, then you can take 4364. Okay, 4364 you can take it. So this is the example, means the other variation of mid square method. Okay, and here also, whatever the technique we are applying to extract, whether it's the first 3 digits and squaring it, or middle 3 digits and squaring it, or last 3 digits and squaring it. Okay, the same technique must be used throughout the process. Means to store all the records, the same technique must be used. For each record, we cannot extract different digits. Okay, it is not correct way. So this is what mid square method. Any doubt in mid square method? Okay, fine. The next is folding methods. In folding methods, we have two types. That is fold shift and fold boundary. Okay, fold shift and fold boundary. Okay, so in fold shift, the key value is divided into parts whose size matches the size of the required address. Okay, suppose if you have, if your address is a 3-digit address, then the key is divided into 3 digits, 3 digits, 3 digits. Okay, so like that it will be divided. Based on that, you can prefix zeros. If required, you can prefix the 0 values. Suppose if the key contains only 8 digits and your index means index values are 3 digits, you cannot convert the 8 digit into 333 equal digits. So in such cases, you can prefix 0, and then you can divide the key into 3 digit parts. Okay, so here the in this example, the key value is a 1 2 3 4 5 6 and 7 8 9. Okay, totally 9 digits are there. Okay, and the required address size, it is a 3 digits. So we are dividing this 1 2 3 4 5 6 7 8 9 into 3 parts. Okay, and after that, what we are doing means the left and right parts are shifted and added with the middle part. So 1 2 3 4 5 6 and 7 8 9, we are performing the addition operation. Okay, and say the result is 1368. Okay, but our address space allows only 3-digit address, so we are discarding the leading digits and we are taking the 368 as a address space. So the details of this particular person, 1 2 3 4 5 6 7 8 9, okay, the details of this person is stored in 368 in this address space, in this index value we are storing it. So this is what the first method, that is fold shift. Okay, we are dividing and shifting to means performing the addition operation, and then from that we are extracting the 3-digit address space. Okay, and what is the fold boundary method? In the fold boundary method, what we are doing means the left and right numbers are folded on a fixed boundary between them, and then the center number. Okay, means the two outside values are those reversed. Okay, means the same concept whatever we applied in the fold shift, the same concept here we are applying, but before performing the addition operation, the first part, the left side part and the right side part, okay, these are reversed. Okay, 1 2 3, it is reversed as a 3 2 1, and 7 8 9, it is reversed as a 9 8 7, and performing the addition operation and discarding the leading digits. Okay, since our address space allows only 3-digit address, okay, we are discarding the 1. So the details of 1 2 3 4 5 6 7 8 9, this particular employee or student record, it is stored in 764th index of the array, or in this address we are storing the details. So this is what folding method. Okay, any doubt in this folding method? In folding method, we have fold shift and fold boundary, and in fold shift we are directly splitting the key into 3 parts, 3 equal parts, and performing the addition operation and discarding the leading digits. Okay, the same concept we are applying in the fold boundary also, but here we are reversing the digits and performing the remaining operation, same as fold shift. Any doubt in this folding method?
Sir,
Yes.
Sir, if we get 4 pairs, then what will we do? How will we reverse the, I mean, for what pairs we have to reverse? For example, here it is saying 2 outside values are thus reversed. In that case also 2 outside values will be reversed, or it's because it will be 4 pairs.
Okay.
Here only three are there. So how will it be done, sir?
Yes, actually we need to split it into 3 equal parts. Okay, so if it is a 4-digit means, okay, based on your address space, suppose if your address space requires 4 digits, then 4 numbers in each place. Okay, in the first means the left side part 4 digits, and the right side part 4 digits, and the middle part 4 digits. Accordingly, you can prefix the zeros in front as the leading values. After that, you can perform the same operation. Okay, either reversed and then addition, and then discarding the leading values, if any. Totally the 3 paths.
Okay, sir. Okay.
Okay. It is based on your address position. Okay, how much address space, address digits is required, but you have to split it into 3 different. The 3 different paths, because the left part, right part, and middle part, totally 3 paths are there. Okay, if your key is more, okay, instead of 9 digits, if it is a 12 digits or 10 digits, let us assume it as a 1 2 3 4 5 6 7 8 9 and then 1. So totally 10 digits are there. You cannot split the 10 digits into 3 equal parts. What we can do means we can prefix 00 in front of the key, then split it into 4 digit 4 digit 4 digit. Okay, the left side part will be 0 0 1 2, then the middle part will be 3 4 5 6, and the last part will be 7 8 9 1. Okay, then we will perform the same operation. So totally 3 parts: left part, right part, and middle part. Getting it?
Yes, sir.
Okay, fine. So this is what our 5th technique, folding methods. And the 6th method. The 6th method is a rotation method. Normally, when we will use this rotation method means only the last part of the key is changing frequently. Okay, so the rest of the parts are remaining constant. Okay, so in such case, we will go for the rotation method. Okay, and this rotation method, normally we will not use it alone. Okay, we will combine this technique with some other hashing techniques. Okay, so the rotation method will be used as a used to improve the efficiency along with the other hashing methods. Okay, in rotation method, what we will do means we will move the rightmost digit to the leftmost digit. Okay, here if you are seeing the original key, it is a 600101, then 600102. Like this, the original keys exist, and we are performing the rotation operation. Then the sequentially changing values 1 2 3 4 5 6. So this is moved to the first digit. Now it will become 160010, 260010, 360010, 460010. But what is the problem with this rotated key? Any idea? What is the problem with the rotated key?
Increasing with the number more than like 100,000.
Correct.
Initially, we are increasing by 1, but here we are increasing by more extent.
Correct. So suppose along with this, if you are applying a modulo operation means, modulo 10 means, so for all these keys, we will get the same address. So instead of modulo division, okay, some extraction algorithm. Okay, extraction algorithm means extracting the first 2 digits alone. Okay, or extracting the first 2 digits and performing the mid square method or the previous method, folding method, that will give the different address space. Okay, so if you are taking extraction portion, okay, extraction means only first 2 digits will be extracted. In that case, the first rotated key, its address is 16. The second one, its address is 26. The third one, its address is 36. The fourth one, its address is 46. Okay, compared to the previous one, this will give the different addresses. Okay, so always we will use the rotation method along with the other hashing algorithm mostly. Okay, so this is what the rotation method. Okay, and rotating the last character to the front of the key minimizes this effect. Okay, so this is what rotation method. Okay, the next is a pseudo random method. I think I missed one technique. Okay, so the technique is just 1 minute. The second technique I missed. Digit extraction method. Sorry to say, I missed this digit extraction method. So digit extraction method, I'll include this PPT, and after that I'll upload this PPT. Okay, so what is digit extraction method means? From the whatever the key available, from that extracting the fixed number of digits, means extracting the first 2 digits alone and use that as a key. or extracting the middle 2 digits, middle 3 digits, or extracting the last 2 digits, last 3 digits. Okay, so this is what digit extraction method. From the key, extracting a specific digits or first digit, third digit, fourth digit. Okay, but whatever the digits you are extracting, the same digits you need to extract for all the records. It is not like for first record I am extracting the first 2 digits. For the second record I am extracting the last 2 digits. You can combine like this. Okay, so this is what digit extraction method. From the key, extracting specific digits and use that as a address. Use that as a address. So this is what digit extraction method. So totally 8 methods are there. Okay, so I missed to include the digit extract method. Sorry, I'll add this and upload it in the Google Classroom. Okay, and the last one is a pseudo random hashing. Okay, so pseudo random hashing means applying some function to generate a sequence of random numbers. Okay, so it is not like it is not equal to the random number. Random number generation means always it will generate some random number. Okay, here pseudo random number means by applying some functionality, okay, based on the seed value, whatever the seed value we are using. If you are using the seed value, for the same seed value, always it will generate the same sequence of numbers. So that is what pseudo random number. Okay, so the last one is generating the pseudo random number hashing. Okay, so here a common random generator number is function is given here, y equal to ax plus c. Here x is the key, whatever the key value we have, that is what x value, and then we need to multiply this with some coefficient. You can choose some coefficient and then add with some constant c. Okay, to get some good address values, what we need to do means we need to choose the a and c as a prime numbers. Okay, then we will get good good algorithm with good efficiency. Okay, so one example is given here, y equal to 17 into 121267. Here 121267 is a employee ID or student ID or some key value. Okay, and then we are adding with 7. Check here, 17 also a prime number and 7 also a prime number. And finally, we are applying the modulo division. So total number of records, so how much records we are having means 307 records. So this is a key value. Okay, and we are performing the modulo operation. Finally, taking modulo by 307 will give the index position. So in that particular index, we will store the record of 121267. This particular person's details. It will be stored in that particular record number or index position. What is the index position means? 41 is the index position. So in 41 index position, we will store this 121267, this particular employee's details. So this is what the last technique, pseudo random hashing. Okay, so these are all the different hashing methods, hashing techniques available. Okay, we will use either any one of these method, or we can combine with one or two methods based on our number of records, how much records we are going to store in the array. Okay, and the key size. Based on all these things, we can choose any one of the hashing method, or we can combine one or two hashing methods and create our own hash function. Okay, and the next is a collision resolution methods. Okay, so what is a collision? When two keys collide at a home address, means if two keys generates the same home address, then we need to store one record in different location or different address. Okay, finding the alternative address. Okay, so that is what there only we will use the collision resolution technique. Okay, we must resolve the collision by placing one of the keys and its data in another location. So finding this another location is the collision resolution method. Okay, so what are the different collision resolution methods available means? These are all the collision resolution method available. First one is open addressing, The second one is a linked list, and the third one is a buckets. Okay, in the first one, open addressing, we have linear probe, quadratic probe, pseudo random, and key offset. So these are all the four techniques available under open addressing. Okay, about each of these techniques we will discuss in the next class. Okay, so before entering into this collision resolution technique, we must understand some basic things, like when you are generating a key, means when your address is generated, okay, where the addresses will be stored in a memory location. Okay, the primary memory location, the secondary memory location, okay, secondary address area. So some factors we need to discuss. Okay, so discussion about the collision resolution method and also the collision resolution technique. So this we will discuss in our next session. Okay, if you have any doubt in our today's session, you can post it in the chat window. I will upload the recorded video today itself. The first two videos and today's video. Okay, everything I'll upload it in the before today end of day. Now I am stopped recording. If you have any doubts, you can post it. Please post your doubts if you have any in our today's session. Saket, it is not possible to say which is the most common based techniques. Okay, so whatever the techniques we discussed so far, these are basic techniques. Mostly, one or two techniques will be combined together and used. Okay, so it is purely based on the key size and the memory space, how much memory space you are having, and the address size. Based on this, it will be decided. Yeah, correct. An array means example for implementing hashing techniques. So tomorrow, after discussing the resolution technique, I'll show one example. Okay, and Divya, for your answer, actually array is a sequential. Correct. Suppose if array contains 100 elements, suppose if you wish to find 98th record, how you will find it? Means the 98th record means it is, you cannot access it by index. The 98th student having some race number. Let us assume that your race number, your record is stored in the 98th record. Then, sorry, yeah, 98th record. Then how you will find your details? It is in the 98th location. Now how you will do it? Normally what we need to do means we will use the for loop. Then using the for loop, yeah, tell me, Divya.
Sir, sorry, please can you repeat the last part?
Actually, we have 100 student records and 100 students records are stored in an array. Okay, and the 98th record is your record. Okay, so you're using your race number, we need to find your record. How you will find it?
I'll go into the 98th index.
You cannot use 98th index. You don't know that the 98th index is your record. Using your race number only, you need to find it.
Okay, so I get it that we have to use some hashing techniques for that.
Suppose if hashing technique is not there, then we need to use the iteration for loop. Then take each record and compare the race numbers. Okay, till 98 records, we need to perform the comparisons. Suppose if we have hashing techniques, so your race number will be converted into some index. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. So from your race number, the index position will be calculated. Okay, so in that particular index, your record will be stored. So whenever we need to search your record, simply your race number and hashing technique. Immediately we will get the index, and directly from that index we can retrieve your record. That is why we are going for the hashing technique.
Yeah, okay, sir, I get that. For that particular purpose, this hashing technique is very useful.
Your audio is very low. Can you type it in the chat window?
Yeah, okay.
And in mid-square method, we have a case where we extract first 3 numbers of the key and square them, which generates 7-digit number. How can we extract mid 4 values? Again, how to extract the middle values? How to extract the middle value means, again, the first, suppose if you are unable to extract the middle values, what we can do means we can make it as a we can prefix some padding values. Zeros we can pad it in the prefix, then we can go for extracting the 4 digits. Okay, the other way is so this is one way. First one is a padding. The other, some other ways means, suppose if you from the 7 digits, if you want to extract 4 digits, means for sure after first 2 digits and first 2 digits must be there and the last 2 digits must be there. Okay, so you can choose any one technique. Either you can leave the first 1 digit and last 2 digits, or first 2 digits, last 1 digits. Okay, so this is also one function. Okay, whatever the function you are applying, the same function must be used in the rest of the records also. Salavika, it is not fixed one. Okay, so you can choose your own function. Either you can append some padding values and then we can find the middle values. Any other doubts? Yeah, hashing is useful for this particular purpose, but an array not being sequential has many disadvantages. Yes, correct. Actually, array means it's a sequential, and tomorrow we are going to discuss about this. Okay, if we are trying to store records in hashing function, okay, using hashing function, again, it has its own limitation. It is not possible to store all the array elements with records, because if we are doing so means we will get more collisions. Okay, so if the hashing function should be efficient, means some part of the arrays must be left empty, unused. Okay, so this is one of the limitation of a hashing technique. Again, compared to the ease of access, if you are looking for ease of access, then we need to go for hash search method. Okay, if you are not worrying about the memory space, okay, then we can go for the hashing function. Okay, so again, as I already told, we have many data structures and many searching algorithms, sorting algorithms based on the application. Okay, our application requires what? If it is a space constraint, means we cannot go for hashing technique. Okay, suppose if it requires very fast access, then we need to compromise the space. Okay, so based on it's purely based on the application's requirement. Okay, for which what type of techniques required for that application. That applications, that particular techniques must be used.
Thank you.
Divya, I hope I answered your question.
Yeah, thank you, sir. Yes.
Okay, fine. If no doubt, no more doubts, we can leave the session. Thank you.